Our lesson for today will be looking at chemistry 1502. The topic for today will be looking at alkene reaction, part 2, lesson series. We'll be specifically looking at free radical addition of HBr. Lesson 103, let us start. We are still busy with the addition reaction onto alkenes. Now, if you can review the lesson videos based on alkene reaction part 1, we had conditions whereby we add hydrogen halides, actually specifically hydrogen bromide, to an alkene together with a peroxide. We said it follows the anti-Markovnikov rule. Now we will look at the mechanism, but you should understand that the peroxides, actually the addition of hydrogen halide, specifically hydrogen bromide with a peroxide, will follow the anti-Markovnikov. But if, let's say, we have hydrogen iodide, Hi, together with peroxides, it will not follow the anti-Markovnikov. The anti-Markovnikov will only be followed when we are using HBr with a peroxide. I hope you understand that. So we'll be looking at free radical addition of HBr. Remember that we always follow a certain general mechanism. So let's say, actually let us review quickly. We know that alkene, it's carbon-carbon having a double bond between carbon and carbon, and we know that our hydrogen bromide, it's hydrogen bonded to bromide ion, and then we normally use ROOR as our peroxide to represent peroxide. So let us look at the mechanism. The mechanism starts with initiation. Initiation is the formation of radicals, but we normally say it's just a step. We don't really consider it as step number 1, which is a formation of radicals. These radicals are formed by peroxide and our HBr, our hydrogen halide. So you know that oxygen, it bonds 2 times with 4 lone pairs. So in this case, we form radicals. If you remember bond fission, it will be simple for you to understand this. It's a fish hook arrow, meaning that we have only movement of 1 electron. Remember that we have 2 electrons here. So homolytic bond fission takes place, and one of the conditions is that we need heat. So we'll have 2 radicals, RO plus another part of RO. Remember that these are the electrons. We call this radicals. And then 1 alkoxyl radical, we call this alkoxyl. This actually one part of the peroxide. One of these radicals will react with our hydrogen halide. Whereby we have 1 electron, fish hook, and this movement of this electron. And then we have another electron, fish hook, because remember we have 2 of them. So one of them will go to the alkoxyl, the other one will go to the bromide. To form another radical, which is Br. This is a radical. This step we call it propagation, whereby a radical reacts to generate another radical. And then from here we can start with our steps. Step 1. A bromine radical adds to the double bond to generate an alkyl radical on the more substituted carbon atom. This is also a propagation. So we have that Br radical which adds to the double bond. So you can say we only have one movement of electron and another electron from the double bond, and another electron will move to this carbon. So you can see the movement. We have two electrons here. One of the electrons will go to the bromine radical, and the electron from the bromine radical will also move towards the electron which was homolytically broken by this electron or this process here. Then one of the electrons will go to the second carbon. And remember that we need a stable radical. So in this case, we can see that we have a symmetric alkene, so it doesn't matter which one will take the radical or will form a radical. So the product, we are going to have Br C with the radical. You can see, and then we have step number 2. Step 2, the alkyl radical abstract a hydrogen atom from the HBr to generate the product and the bromine radical. So we have Br, which was formed from, it's actually a radical which was formed from step number 1, reacting with HBr. Another fish hook. To form a product like this. This will be hydrogen plus bromine radical. And then this bromine radical will be taken and be used to step number 1. So you can see that the reaction is continuous. But our achievement is to have this, an addition of hydrogen halide or specifically hydrogen bromide added to alkene. And you should know that in this case, if we had a asymmetric alkene, this Br would be added to the least substituted. Remember that if we react alkene with HBr together with peroxide, the anti-Markovnikov rule, it is applied. The question is, why is it so? Now remember that we are dealing with stabilities. In this case, the stability that we follow is the stability of radicals. You should know that tertiary radicals are more stable compared to primary radicals. More stable compared to secondary radicals, more stable compared to the primary radicals, and we have the methyl radicals. So when you talk about a tertiary radical, it is actually the same as the primary, secondary, tertiary alkyl halide. if it is connected to 3 other carbons, the radical connected to 3 other carbons, it is a tertiary radical. And then a secondary, it's a carbon attached to 2 other carbons. Here we can put hydrogen. And then, oh, by the way, this is a secondary radical. Primary radical, the radical attached to only 1 carbon. It is a primary radical. And then we have a methyl radical, which it is attached to only hydrogen. There's no other carbon. So in this case, we need a stable radical for this particular reaction. Now let us look at an example to explain this. For this one, we are going to use an unsymmetrical alkene. Let's use, okay, it's butene. Let us put a methyl here. Let us put a double bond here. Reacting with HBr, the presence of peroxide. So we know the first step is the initiation and the propagation. Then we can just skip those and go straight to the step number 1. So step number 1, we need a stable radical. So we have our alkene reacting with a bromine radical. So what will happen is that we are going to have this movement of electrons. Now the question is the bromine radical going to be attached to this carbon or this one? Remember that we are looking for a stable radical. If it is attached to this one, to this carbon, so let me use a different color. If it is attached to this carbon, we are going to have our Br is here. We are going to have, oh, by the way, there's also a movement of electron here. We are going to have this type of a radical. Now, if it is attached to this carbon, we are going to have a radical like this. You can clearly see here. So between 1 and 2, which one is a stable radical? Now you can see that this radical, it's a tertiary radical. This one is a primary radical. So this one cannot be part of the synthesis of our reaction. So this will be our product. And then step number 2, this radical will react with HBr. to form Now you can see that following this mechanism, it has yielded an anti-Markovnikov product. Because according to the Markovnikov product, by just looking at this, we can clearly see that this is tri-substituted, this is di-substituted. So our halide should have joined the most substituted carbon, but instead it has joined the least substituted carbon due to following the most stable radical. We need a stable radical, then it will form an anti-Markovnikov product. We can go on looking at other examples, but just to make sure that the lesson video is not too long, I will be posting questions. Now, from the last lesson video, I posted questions whereby you have to answer those questions, and then you send them to me. Then we can discuss those questions to check if you really understand. So the questions for this lesson video. The first one, you have to show the mechanism. We have 1-methyl cyclohexanol. Actually, we have to use an alkene. So let's say it's 1-methyl cyclopentene. React this with HBr. In the presence of this peroxide. And you must make sure you show the mechanism, starting with the formation of radicals. And please, when you submit these answers, you simply tell me that is the lesson, tell me the lesson video and the answers, so that it will be simple for us to actually discuss this. So you should show the mechanism, and also after writing down, after drawing the product, give the IUPAC name of that particular product. That's it for this lesson video. This is Mahula SJ. Thank you very much.